So now let's find out why our smoke doesn't move anywhere. Just stay in the position. Well, in real life, again, what's wrong with the smoke? Why is it rising up? Well, all you know from physics that all hot air is rising up and the cold air is falling down. So because the smoke is production of fire, so we have some temperature here, right? Some peak temperature. The smoke mostly is hotter than the surround air and is rising up till it cool down and dissipate. So the same principles, and here in Houdini we need to add a temperature field to the density to get this smoke up. How we can do this? We can apply another operation, and we have another field ring. We have a scalar. Actually, there is two field rings. We have a scalar and vector. So vector mostly using for the velocities, and the scalar is fields like density and the temperature. So we can take our density field as a source and send this density field to the temperature. Okay, right here. So we're gonna use the same density field from my source, but we send this information into two separate fields like a density and temperature. I use the same rank, the same scale, and same operation. So we need to add a temperature in each frame or subframe, and voila, now it works. Our smoke is rising up. It's working. It's going outside of my container, but it's working. So let's just increase this container a little bit and go to the y-axis and make it, I don't know, like a 10, and the center is like a 4 maybe to have a closest edge over here. So let's stop it, and I want to increase it. So again, it's a little bit hard to calculate, so I get back to my 0.1 settings. So it's a little bit more quicker result. Now you can see that the smoke is rising up. Using the temperature, we have an advection. So basically, what is advection? The advection is when we push our information through the voxels. So voxels themselves, they not moving anywhere. They stay in their position and doesn't move. We have just information and try to advect this information through the voxels, right? So we transfer information. We create an advection of the density using different setups. This advection can use the velocity field, but we don't have velocity for now, so we're going to use the temperature field. And temperature causes this smoke rising up. So in my case, if I have the density and temperature field the same, it's good. Okay? But sometimes you can create two separate fields for the density and for temperature inside of your source. So there's a few different setups here. Again, we can go here and create another VDB from polygons and create another field called temperature. Okay. We can make some changes. We can add some noise or something like that. We can add another scale and then merge those elements together. Okay, and then we're gonna have and the density field and the temperature. So we can change something from here, beginning from this VDB from polygons, you can change something and then merge them. If you will use the same density field and just create another temperature, we can use the name node. So we can add a name node, connect this name to VDB from polygons, reconnect it here, you can switch to make proper connection. Okay. And you said, okay, I take a density field and rename it to the temperature. So we're going to have the same setup, density and temperature. And again, if you want to, you can correct something here, paste some nodes, I don't know, make this temperature bigger or add a noise or something like that. We can work with this a little bit later. And then inside of your DOP network, we said that we will use the same source name at temperature. So in my case, it will have the same result. Again, it's working. So there is a few ways you can add your temperature field using the same name or using the name of a density, or whatever name you want. You need to understand that all what you need to make proper is to paste your target field properly, because if you type something like that, solver doesn't know what to do with this field, okay? But from source volume, you can use any name you want. Just you need to have a proper rank, because you need to choose between the scalar and vector. All right, so that's fine. But there is another thing I want to show you, is how we can control our container size. In my case, I don't know how this smoke will, move, and maybe I want to increase this container in the x-axis or the axis or y, I don't know. So sometimes it's very helpful if you want to add another node which will control your container size. All right. It will be helpful to save some resources, because let's say in frame 2 I don't need to use all my voxels inside of this huge container, just over here near my source, because there is no any density field here, so we don't need to calculate nothing here. We don't need to spend any resources over there. So to do that, we can use the node, call it gas resize fluid dynamic. It has a long name, but it's very useful. We have a second connection which is calling the pre-solve, and that's what I want to use as a pre-solve. And the gas resize fluid dynamic, as you can see it on the first frame, just decrease my container size to my source. So now it will increase my container just on this region, on those regions where we need to have this container, okay? So it's, again, it saves some resources, especially on the first frames where we don't need to have such a huge container. And sometimes it's very helpful if you go into max bound, there is a checkbox which is called clamp to maximum. And this means that it will not expand this container more than the maximum value. And the maximum value is our setup over here. So it will not push those sizes even more. It will stay like here. But we can allow this. We can uncheck this stuff. Now this container will expand as much as it needs. So there's no like a limit for now. You can move anywhere you want. Well, in fact, not anywhere you want, anywhere your density field will expand, because reference field is density by default here. So where it goes density will go the bounding box. Well, our container in this case. It's looking like a bounding box, but it's now a container. So you can use the different setups for the padding, for the substrate threshold, and very useful is padding scale for different axes. So now you can see that we have a little clamping over here on the upper edges. So we can go to upper padding scale for the Y and make it 2. So you can see that it creates a bigger gap between the our density and the upper side of the container when you try to calculate where it's moving. It's very important when you have a very big expanding speed, like an explosions or something like that. You need to increase those setups, and you can try to enforce boundaries. Let's say it's helpful for the y-axis. In my case, I don't have any expanding on the -y, so we can uncheck all those stuff, leave just -1. So it doesn't matter what happened, our container will not be bigger on the -1 direction. So definitely in many cases we want to clamp to maximum, because if you have like a camera from this view and on frame 48 is going outside of my camera, and there is no reason to have container outside my camera view. So I don't need to have a simulation there just to spend some resources. So on a final setup, you definitely need to work with your finals, with your maximum setup for the container size. But if you want to test something, it's a very good idea to allow gas resize fluid dynamic to make this for you. All right, so that's fine. Now we have temperature. we have some simulation, but this simulation is looking not very good. It's looking more like a mushroom and it's very flat. So how we can apply some noise for this simulation? Let's find out.